If your graphics card is overheating, making a lot of noise, and consuming a significant amount of power,
Burn, baby, burn.
then I have very good news for you. In this video, I'll show you how to make your graphics card consume much less power while maintaining the same performance, or even slightly boosting it, which will also lower the temperature and thus reduce noise. Some of you will probably say, Pavel, we already know what undervolting is and almost everyone has tried it. Exactly, almost everyone has tried it, but the truth is that very few people stuck with it because in practice the benefit was minimal. Even if the temperature dropped by a degree or two and the performance in one game stayed the same, in another game it noticeably dropped, and in a third game it would just crash all the time. And there's nothing strange about that, because all the tutorials, guides, videos and articles were wrong. Oh no! And it's not just that some local computer magazines were wrong, but even global websites or YouTube channels with several or even over a dozen million subscribers were doing it incorrectly too. Snap! Some were less wrong, others more so. And well, I'm not able to comb through the entire internet. But since the biggest media outlets in the industry were giving out incorrect information, it's very likely that the vast majority of you were also going about it the wrong way. However, I finally took on the topic myself, and as you know, I usually dig very deep. That's so I can prepare the most reliable and comprehensive video for you. This is Pavel and you're watching the TechManiac HD channel. Let's get into the video. This video is made possible thanks to the support of the GVG Mall platform. It's a huge store specializing in keys for PC, Xbox, PlayStation and even Google Play games. You can get practically everything here, from Steam gift cards to software like Office or Windows. If you're still struggling with that annoying message reminding you to activate, go ahead and visit the link in the description right now. You'll get the key in a few minutes. Just paste it into the activation settings. This will not only make your copy of the system genuine, but also allow you to upgrade to Windows 11 without any issues. You can activate Office and link it to your account just as easily. And with the code TMHD, you'll get an extra 20% discount which can go up to 30% during various holidays and events. Stop overpaying and visit the website now. To assure you that you're not wasting your time anymore, let me present you with a few undeniable facts. On the mobile version of the RTX 2060 with a 90-watt limit, the average increase in energy efficiency was 32%, and that's with both a boost in frame rates and greater frame rate stability. The result is downright spectacular, but laptops from the lower or even mid-range are heavily limited by low-performance cooling systems and low power limits for the GPU. Performing the same procedure on a more powerful RTX 3000 series model in a laptop that already has a 130-watt limit and a powerful, efficient cooling system that draws in air both from the bottom and the top, we still achieved nearly a 19% increase in energy efficiency while also boosting the frame rate. In this video, I'll show you how to do two levels of undervolting. The first boosts the frame rate while reducing power consumption, and the second is a deeper one. A more accessible undervolting, which will significantly lower temperatures, will of course improve overall acoustics and minimize energy consumption, but it may slightly reduce the number of frames. By how much? Take a look at this. On a desktop RTX 3090, I managed to lower power consumption by almost 100 watts, losing only 2 to 23 frames. The temperature dropped drastically, and I think everyone who owns such a card knows that 10 degrees less means the computer runs twice as quietly. However, the true masters of energy efficiency are the latest RTX 4000 series cards, made with 4nm lithography. Here, we achieved a 48% increase in energy efficiency per frame.
Hey, that's pretty good.
But don't worry, I understand that not everyone has this kind of hardware, which is why my team and I have spent the last few weeks performing and repeating hundreds of test procedures using different graphics cards and laptops. If you have an older system, you can still expect a 10 to 25% improvement in energy efficiency here. I'm a skeptic myself, and until I see hard evidence and data, it's hard for me to believe these kinds of claims. If you think this is too good to be true, I think I know what's on your mind. Because it seems impossible that companies making graphics cards would set the voltage so poorly. After all, this goes hand in hand with much higher power consumption and higher temperatures, which is definitely not in their best interest.
Good point.
So you might say it doesn't make sense and undervolting must be a scam.
Unless there's some dark pact where power plants share the profits from the ever-increasing energy prices.
Some may believe in that conspiracy theory, but the truth is actually much simpler. The main reasons include the manufacturing process, compatibility, and in the case of the latest graphics cards, or even processors, squeezing out every bit of performance, even if it costs an excessive amount of energy. Just briefly and in a very simplified way, I'll explain that silicon wafers, on which microprocessors are printed and cut, are not free from defects. It all depends on the quality of the wafer. From lithography to refining the manufacturing process, there will always be some rejects that are completely unusable, but even everything that gets accepted is still not perfect. And if one processor reaches the intended clock speed at, let's say, 900 millivolts, another one, to still work stably at the same clock, will already need 950 millivolts. Probably everyone has heard about the silicon lottery, or that one processor can be overclocked better, another less so. When it comes to undervolting, exactly the same principle applies here. As you can probably guess, no matter what kind of business it is, there's nothing worse than a product return, giving the customer their money back, and also covering the shipping costs or even bearing the costs of customer service. For peace of mind, if only to keep the company from going bankrupt, it's better to leave a healthy safety margin. Let's say 20% higher voltage just in case, so that even the unluckiest chip always works stably. There's still one more issue that the companies making integrated circuits have no control over. For example, what if the user has a cheap and terrible power supply in their computer, which doesn't maintain the intended voltages at all, has voltage drops, and at the same time is susceptible to other disturbances from the electrical grid? A neighbor uses a hairdryer, causing his game to crash. Now, do you see why a higher factory voltage is better? So as long as you have a decent power supply and you didn't get the worst and unluckiest chip that barely passed quality control, you can benefit a lot from undervolting. Another thing is that over the years, after many heating cycles and after passing a significant amount of megawatt hours through the chip, it undergoes degradation processes which causes resistance to increase. So, does that mean that as it ages, it needs more and more voltage for the chip to actually keep working at all? So manufacturers have to do this, but higher voltage leads to faster degradation, and that's already a loss for the user. As a result, by undervolting, you extend the lifespan of your hardware. You won't violate any warranty conditions here either, and even if you undervolt too much, the worst that can happen is your game closing or, in the worst case, your computer restarting. And according to expert opinion, the chance of physically damaging your hardware is absolutely zero. To perform this procedure, we'll use a program called MSI Afterburner. If you haven't installed it yet, you'll find a link in both the description and the pinned comment that will let you download it, and always make sure to download it only from the official source. If after installing the program it looks different than what you see on my screen, it means you have a different skin because there are many to choose from. It doesn't really make much of a difference, but to be able to easily follow along with what I'll be discussing and showing compared to what you see on your screen, it might be more convenient for you to switch to the same skin. In that case, go into the program settings either by clicking the gear icon or the button labeled Settings, scroll to the User Interface tab and select the one whose name you see now on the screen. If you're using a TV or a monitor with a higher resolution, which makes the program window too small, keep in mind that you can increase the scaling at the bottom. However, if this option doesn't work properly for you, I'll leave a link in the description to a guide that will help you activate advanced scaling. Before you close this window, go back to the first tab and make sure that in the main graphics processor field, you haven't accidentally selected the integrated graphics, but actually the one you want to undervolt. It's time to start the actual procedure. To do this, you need to run a process that will boost your graphics card's clocks to their working values and at the same time give it enough workload so that we can test the stability of the new settings. However, not every game, and even less so every synthetic workload, is suitable for this. Most old materials about undervolting suggest using the Heaven benchmark, but in reality it's not very suitable and you can end up wasting a lot of time with it, and your settings might still turn out to be unstable later on. That's why I'd like to suggest Fortnite to everyone here. First of all, because it's completely free, so anyone watching this guide can download and test it. Secondly, the settings. When undervolting, it's important to properly and fully load the graphics card, but not to overdo it. In short, we want to force the highest boost clock. Fortnite has a wider range of settings than any other title. In performance mode, it will run on what we call a potato, for example, a computer with an old i3 processor. On the other hand, with the implementation of the new Unreal Engine 5.1 graphics engine, it can seriously challenge even a graphics card worth 10,000 zlotys. The game runs smoothly in borderless full-screen mode, so by using the Alt and Tab keys, we can freely switch between the game and Afterburner. Also remember to turn off vertical sync and remove the frame rate limit here. At the bottom of the graphics settings, you can enable the display of frames per second, which can also be helpful. And most importantly, inside the Career tab, you'll find Gameplay Replays. Just play the recorded replay. It puts the same load on the system as real gameplay. Interestingly, even when the replay is paused, the system and graphics card load doesn't drop, which gives us perfect conditions to calmly and consistently find the ideal clock speeds at the desired voltage. Most importantly, it's a real game, not just a synthetic benchmark. It's also worth noting that it's quite sensitive to any instability caused by too aggressive undervolting. And at least from my observations, while many other games might crash after an hour or two of playing, Fortnite can check if we've gone too far with the settings in just a few minutes, or sometimes even in a few seconds. Just take a look at how it works. I intentionally set the clock speed too high here, but that's just to show you what you should pay attention to. The game runs in the background, but we occasionally see strange flashes and artifacts. Clearly, something's wrong. If you notice similar behavior while performing the operation, you can click the button to restore factory settings, which will immediately fix the problem. If you don't make it in time, Fortnite is kind enough to close the game window and give us a nice message saying that it has crashed. Then you'll launch the game again and slightly adjust the settings, repeating this process until you find the ones that are completely stable. Okay, I'll show you now what the process of finding those stable clock speeds and voltages looks like. When the gameplay is running in the background, go to the Afterburner window and click the icon with the 3 bars. Alternatively, press Ctrl and F on your keyboard, which will open the frequency curve, that is, the clock curve editor. Adjust the window size so you can clearly see each of the individual dots, because we'll be working with them the most now. If you've already made any changes before, click the reset button to restore default settings and observe for a moment what clock speeds your graphics processor is running at. You can see this value in the top left corner of the program window, and you can also read it from the curve editor itself. If you look more closely, you should notice a subtle dashed thin line. Click the little dot where it ends, and the corresponding voltage as well as the clock frequency will be highlighted. If the main Afterburner window doesn't display the current voltage, check if voltage monitoring is enabled in the program's general settings. If that doesn't work either, you'll just have to rely on what the curve shows. This is perfectly valid data, but they're simply harder to read. We'll start by looking for the lowest stable voltage for a relatively higher core clock. First, I'll show you how I perform the procedure on a laptop with an RTX 3070 Ti, because the clocks and voltages for this chip are very similar to all desktop cards, as well as laptop chips from the RTX 2000 and 3000 series. It's best to choose such settings in the game so that, as much as possible, they allow your chip to reach the highest possible values. As you can see, in my case, the clock doesn't exceed 1785 MHz because in laptops or other mobile devices, it's hard to achieve anything more. Just in case, you can verify the maximum clocks of your card by running any game, but one that's much lighter. Trackmania is a very fast and also free game, and as you can see, this one also isn't able to go above 1785 MHz. The fact that we see the highest value of 1965 at the top of the chart doesn't mean it could actually reach that, so don't pay too much attention to it. What's important is the clock speeds your chip is running at, so click the point where the dashed line goes down to. This way, you'll confirm what voltage is being supplied to the chip, and as we can see in this example, exactly 925 MV is being delivered. I'd like to lower it by 100 MV for the same frequency. Why 100 just because? There's no special rule here. Well, lowering it by 100 MV while keeping the same clock speed will maintain performance and should noticeably reduce power consumption, temperatures, and consequently noise, so why not give it a try? So now I'm looking for the point that corresponds to 825 MV, and once I have it selected, I hold down the Shift key to highlight the entire graph so that it's gently highlighted in dark blue. Now, using the arrow keys on the keyboard or the mouse, I set the point to the level of 1785 MHz. This way, you'll raise the clock across the entire range of available voltages, and that's exactly what's crucial for properly performing undervolting. Now, while holding down the Shift key, change the selection on the graph so that the point we set and everything to the right of it is highlighted in blue. You can drag the selection either from the left before the point or from the right, pulling a bit past it. No matter how trivial it may seem, the selection must start exactly between these 2 points. Otherwise, the next step will not work. That's why it's worth expanding this window. After selecting, don't release the Shift key, but press Enter. You'll see that the gain value will change to the target value, then press Enter a second time, still holding the Shift key. You'll see that the curve beyond the set point has flattened. This way, the graphics processor won't use higher voltages. To test the current settings, click the Apply button in the main window of the program. It's worth watching for a while to make sure everything is working stably. If nothing goes wrong, click the floppy disk icon and save the profile, for example as number 1, as the first level of undervolting. There are still a few things worth knowing about the Afterburner program. If you want the profile you set and last activated to be automatically loaded when you turn on your computer, just click this button with the Windows icon. On the other hand, if you have several profiles saved and want to switch between them instantly, even while gaming, go to the Profile tab and assign them shortcuts. It's a great and convenient solution. And if you want to display and monitor any hardware statistics, whether it's the CPU or GPU, you can activate them here, or of course only the ones you want. I personally use another program for monitoring, which allows me for deeper analysis and customization. If you want to see a dedicated video where I discuss displaying statistics in depth, leave a like and a comment. I'll quickly show you now that the procedure really worked. I'm turning on my sensor overlay, and up here, labeled as GPU voltage, you can see the current voltage for the graphics card. It's shown to 2 decimal places, which means it rounds up slightly. After resetting the Afterburner settings, the voltage jumps up by 100 millivolts, which makes the GPU draw between 75 and 80 watts of power. Now I'll click the first profile we created and confirm its setting, which immediately lowers the voltage, and as a result, the power consumption also noticeably drops. It's possible that your card can easily maintain even higher clock speeds, or what you've set now might turn out to be unstable. Let me show you how to make slight adjustments. To check higher clock speeds, now select the entire graph while holding the Shift key, click a point, and use the arrow key on your keyboard to increase the value by 15 MHz. Yes, my friends, it always has to be 15. At least that's how it is with all NVIDIA cards on which I've performed this operation. If you change the boost value, whether you increase or decrease it by 1, 5 or 10, you'll notice that the card will never maintain the frequencies it sets for itself. It will always be a little more, a little less. After raising the entire curve to 1800 MHz, I again select the range I want to flatten. Still holding Shift, I press Enter for the first time, then a second time, and confirm these settings. The game keeps running, there are no artifacts, nothing unwanted is happening. Of course, before you start celebrating complete success, let the replay run in the background for a while, and if everything is fine, maybe take another 15 MHz step up. Alternatively, if any warning signs appear, of course, take a step down. But how do you take a step down? It's very similar, just remember to always, absolutely always, select the entire chart first and only then lower the desired point. Select the frequencies to flatten with Shift, press Enter twice, and voila, it's done. If you want, save the profile again. However, Afterburner isn't perfect, and sometimes the saved profile can slightly, well, as you can see, shift things around a bit. Then you need to flatten the value at the desired point again and save the profile in the same place. I spent a few hours like that in several games, and not once did I experience any stability issues. Which reinforced my belief that 1785 MHz at 825 MV on this particular hardware is absolutely stable. Now I'd like to find clock speeds for an even lower stable voltage to maximize energy efficiency. If you've already set and verified the first level of undervolting, setting the second, third or even fourth one is incredibly easy. In theory, it would be enough to flatten any point for a lower voltage, because if the higher ones were stable, then the lower ones will be as well. But the truth is that lower frequencies also require lower voltage. Notice that the first profile at 750 MV keeps the clock at 1605 MHz, which would be fine if we want to do it quickly and forget about it. But if you want to create an advanced and more refined second profile, then again select the entire graph and pull it even higher. I can tell you that even after raising it by another 45 MHz, my system still didn't show any instability, which resulted in even higher energy efficiency in terms of generated frames. Anyway, the graph where I also included this value will illustrate it best for us. The green bar clearly shows us how many frames the card generates for every 10 watts of energy. Factory settings and the first level of undervolting are separated by nearly an 18% increase in efficiency, and you don't lose a single frame. Interestingly, you still benefit here, but why? Because at factory settings, the GPU clock frequency was constantly jumping, while the second level of undervolting gives you a 38% increase in efficiency. Just take a look. Instead of 113W, the graphics card was drawing a modest 82 watts, and the average frame rate dropped by, well, just one frame. It's true that the 1% low shows us that in more demanding moments, lowering the clock to 1650 MHz took its toll, but it isn't equally important in every game. So let's take a look at how Assassin's Creed Valhalla performs. Here again, the factory settings turned out to be worse in every possible way compared to the first level of undervolting. It's worth pausing here and seriously considering performing this operation not only for yourself but also for all your friends. The data speaks for itself, but this is a laptop, and yes, a lower temperature might be nice because it also means less noise. But is that 30 watts lower power draw and a few more frames really worth the effort? So if that's still not convincing enough for you, take a look at how much undervolting can change when it comes to a real graphics card. The RTX 3090 isn't one of the most energy-efficient graphics cards to begin with, but notice that by cutting almost 100 W of power, I only lost about 3 frames per second, and the 1% lows even improved. Believe me, having 100 W less makes a huge difference, and it's not just about the graphics card itself. The fans do spin a few hundred RPM slower, but even the power supply in the computer is less audible, and all the other fans can also run much quieter. Also note the initial undervolting level. It may have only cut a modest 25 W, but look at how much of an impact it had on raising the 1% lows, better smoothness, meaning less stuttering. The thing is, on factory settings, every time the card hit the 350 W limit, the amount of power was brutally cut, which caused clock fluctuations and a drop in the number of generated frames. That's why undervolting turns out to be such an effective solution. With Assassin's Creed, my third level of undervolting also saves nearly 100 watts of power, while only cutting about 4.5 frames. But it also lowers the GPU temperature from 67 to 57 degrees, even with the fans spinning much slower. Is it worth it or not? Write in the comments if you like this solution. I hope I managed to spark your excitement about this topic, but since the video is getting quite long and YouTube doesn't really like that, I'll split it into 2 parts. And oh, things are really going to get interesting there. We'll be working on undervolting older GTX series cards because you can get great results with them too. There will also be a slightly sad part, because I'll explain to you why the previous undervolting methods actually didn't work. Some videos on YouTube or articles even caused more harm than good. That's why this is a video you need to watch, especially since I'll also show you how to perform this procedure on newer chips, because the RTX 4000 series operates at completely different clock speeds and much higher voltages. But since these are pushed to their limits, the benefit of undervolting can actually be even twice as high as on older chips. The video will be available in a week, unless it's already out, then you'll find the link in the description. Leave a like and a comment, and see you in the next one.